So question 2 of exam 1 is asking us to compute the volume of the solid formed by revolving the region bounded by the graphs y equals x squared plus 1, y equals 0, and x equals 1 about the y-axis using shell, disk, or washer method by A, sketching the region, B, finding limits if need be, C, finding the height and radius of the shell, D, setting up an integral as the volume of the solid, and E, finding the value of the integral. So first we'll start with part A, which is asking us to sketch the region. And we know our y is equal to x squared plus 1. We'll plug in some x's. So -2 to -1, 0, 1, and 2. -2 squared plus 1 is equal to 4 plus 1 is 5. -1 squared plus 1 is equal to 1 plus 1 is 2. 0 squared plus 1 is equal to 0 plus 1, or 1. And 1 squared plus 1 is equal to 1 plus 1, or 2. And then finally, 2 squared plus 1, which is equal to 4 plus 1 is 5. And using these points that we obtained, we'll sketch the region. We know the bounds are from y equals 0 to x is equal to 1. So we'll have our y be here, our x is here, and our 1 bound here. And we'll start plotting our points. The graph doesn't have to be pretty, it just has to convey what the graph looks like, so it's easier for us to understand and visualize it. So our first point, -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. Now, if we recall, we're revolving about the y-axis. So then I'm going to revolve it around our graph, like so. And the region we're looking for is this underneath the curve, but revolved around. I'll just move it lower for us. Now that we have our graph, we'll find the limits. Well, the limits are given to us, so A is equal to 0, and B is equal to 1. Now part C asks us to find the height and radius of the shell. So I'm just going to rewrite that. Now the reason that your limit is at 0 is because it's revolving around the y-axis. So it has to be 0. That's where your function starts and ends, between 0 and 1. So now we're at part C, finding the height and radius of our graph, or the shell, because we're using the shell method here. So h of x is equal to our function, because it's everything underneath our function, and that's our height. So everything underneath our function, from here and upwards, that's how our function goes. So that would be the height. So h of x is equal to x squared plus 1. And our r is equal to x, because x is everything between 0 and 1. Revolved around. Now moving on to part D. Part D is telling us to set up an integral of the volume of the solid. Looking at our graph, we can see that we'll have to use the shell method, so we'll have to set up our equation properly. So A, the area of a cylinder, is A is equal to 2 pi r times h. So writing that in terms of volume, it would be the integral from A to B, 2 pi times r times h, r of x times h of x. dx, because we're integrating. Now using this, we'll plug in the values that we have up here. So really, we have the integral from 0 to 1, 2 pi. Our r of x is just x, and our h of x is the function, x squared plus 1 dx. Now I'm going to rewrite it, and we'll take out the constant of 2 pi. So we have 2 pi integral from 0 to 1, x times x squared plus 1 dx. From here we can distribute the x, and then we end up with 2 pi integral from 0 to 1, x cubed plus x dx. I'm going to expand our function just so it's easier to look at and know what we're doing. So we have 2 pi times the integral from 0 to 1 of x cubed dx plus the integral from 0 to 1 of x dx. Now these are much simpler to integrate now that we have them separated like this, easier to look at. So I'll integrate the left side first, which is the integral from 0 to 1, x cubed dx. When we integrate this, we simply get x to the 4th power over 4. From 0 to 1. Those are the bounds. Plus, and now we'll integrate the right side. Integral from 0 to 1, x dx. And this is also simple to integrate, and we end up with x squared over 2 from 0 to 1. Now we can't forget our 2 pi that we left up here, so we'll plug that in as well in our new rewritten function, and we'll plug in the bounds for this next step. So we have 2 pi times 1 to the 4th power over 4 minus 0 to the 4th power over 4 plus 1 squared over 2 minus 0 squared over 2. And these are much simpler to look at and solve now that we have them. So I'll rewrite it once again down here. And we have 2 pi times 1/4 plus 1/2. And then we can combine the 1/4 and the 1/2 by converting the 1/2 to 2 over 4 by multiplying both the top and bottom by 2. So we have 2 pi times 1/4 plus 2/4. Now that they have the same denominator, we can combine them. So we have 2 pi times 3 over 4. So that means that we can also simplify the denominator of 4. And we end up with 3 pi over 2 as our answer.